Astronomers are in shock after James Webb's most recent revelation from the remote frontiers of the universe. The observation is so extraordinary that it has thrown long-standing theories of astronomy into question. Something utterly unexpected has turned up in the void between galaxies, an object glowing with strange characteristics that no scientist believed possible. At first, researchers suspected a lensing error or an imaging flaw. But detailed checks confirmed the phenomenon was real. What makes the discovery staggering is how it completely contradicts established models of how cosmic matter and structure evolved. The emissions and patterns radiating from this anomaly overturn core lessons found in decades of astrophysical research. Among astronomy's groundbreaking discoveries, few have shaken cosmology's framework more than James Webb's capture of the primordial galaxy known as JD's GSZ 131, detected a mere 290 million years after the Big Bang. This minuscule system exists far earlier and richer in elements than theory ever allowed. Conventionally, the first generations of stars were expected to be nearly pristine, too young to have produced heavier elements. Yet, Webb's detection revealed the signature of oxygen and other metals, forged through ancient supernova explosions long before anyone thought it was possible. This discovery shattered the gradualist view of cosmic evolution. Nestled in a core only 600 light-years wide, the galaxy supported billions of stars erupting in violent cycles of birth and destruction. The findings sent shockwaves through physics, collapsing established models and forcing experts to recalibrate the story of cosmic chemistry. JSZ 131 blurred the separation between the infant and adolescent stages of the universe, exposing an era of rapid creation where complexity rose far faster than expected. Rather than emerging slowly, the cosmic dawn ignited in a furious blaze of light and activity, offering a new perspective on how suddenly the universe became fertile ground for structure. Even senior astronomers admitted they were stunned, struggling to understand how such mature, element-rich galaxies existed so close to the beginning of time. The urgency of the finding triggered special sessions at both NASA and ESA, prompting scientists to suspend plans and pore over reams of fresh data. This single target has begun to dismantle decades of well-established assumptions about the universe's origins, a reminder that Webb continues to reveal objects beyond imagination. Unlike optical telescopes that mimic human eyes, Webb is tuned to the infrared spectrum, detecting the faintest warmth from the most distant corners of space. This supersensitivity revealed objects easily missed by Hubble and its predecessors. To picture the telescope's capability, imagine something that looks like empty darkness, and then Webb uncovers a massive structure hidden there, with its golden mirrors spanning an area larger than a tennis court. Webb collects light that has traveled billions of years across the intergalactic void. Its detectors are so refined they could sense the body heat of an insect crawling on the surface of the moon. Through this unmatched vision, Webb has exposed early galaxies glowing with oxygen as soon as 330 million years after the Big Bang, overturning predictions about when stars began enriching the cosmos with heavy elements. It spotted Wolf-Rayet stars already pumping out dust grains and organic compounds, implying the raw ingredients for planets appeared almost at the dawn of time. Inside the Tarantula Nebula's thick clouds, previously hidden megastars came into focus, shaping colossal columns with their radiation. On smaller scales, the telescope showed exoplanets and ring systems in sharp detail, even tracing storm activity in Titan's methane atmosphere as towering clouds swept across the sky. Webb has also illuminated the invisible gravitational arcs betraying the presence of dark matter and intermediate mass black holes tucked into fragile dwarf galaxies, findings that have already challenged our understanding of how galaxies form and evolve. Piece by piece, its snapshots present not just a universe that is stranger than imagined, but one that is richer, more explosive, and far more complex in its earliest moments than cosmologists ever allowed themselves to believe. Under the stark eye-hole of supernova 1987A to the ethereal glow of Uranus's polar rings, each revelation redraws the limits of expectation. Webb's findings aren't gentle corrections. They're seismic jolts to our cosmic story, proof that reality still hides wonders beyond imagination. It's exhilarating and radically transformative, aimed at this enigmatic patch of sky. Webb didn't return a smudge. It resolved razor-sharp features in an object that strains the rules of physics as currently framed. Its instruments recorded unconventional energy signatures streaming from a structure, signals unlike any cataloged class of cosmic source. Even more astonishing, the target wasn't a special case. It emerged from a field considered routine. That implies similar impossible objects could be scattered throughout the universe, hiding in data long thought ordinary. Ancient photons carry an improbable tale. This bizarre formation shines from nearly 13.5 billion years in the past, skimming the edge of cosmic dawn when the universe was roughly 300 million years old. Here's the paradox: by standard models, the ingredients required to build such a system shouldn't have existed so soon after the Big Bang. It's the technological equivalent of uncovering a smartphone in a pharaoh's tomb. The necessary parts weren't supposed to be there. The spectral patterns point to heavy elements that, in theory, should have needed billions more years to accumulate in meaningful amounts. What stuns researchers most is the hint of intricate chemistry at a time when the cosmos was overwhelmingly hydrogen and helium. When the James Webb Space Telescope gazes into this epoch, it collects photons that have crossed more than 13 billion years of space-time. These faint messengers arrive from an age when the universe was only a few hundred million years old. Rather than a calm, incremental buildup of structure, Webb sees roaring furnaces of star birth churning out heavy elements at astonishing speeds. Early galaxies appear unexpectedly massive and metal-rich, their spectra revealing pasts marked by intense supernova cycles. Dust seems to coalesce with startling speed, wrapping newborn stars in complex, protective shrouds. Black holes weighing millions of suns already thunder within nascent galaxies, appending the assumption that such giants need eons to form and fatten. Gas streams along unseen filaments like arterial rivers, fueling star factories with relentless flow. Even faint nebular light contradicts expectations, exposing forms molded by fierce radiation and magnetic fields stronger than prevailing theories predict. Each startling detection forces a revision of simulations and a rethink of when key cosmic transitions occurred. This ancient light doesn't murmur a familiar tale, it delivers a shock, unveiling a universe more untamed and surprisingly mature at its dawn. Timelines are being redrawn. Some researchers now float possibilities ranging from locally accelerated evolution in select regions to more exotic ideas, like relic structures predating the Big Bang that somehow persisted. Webb's team has already cued deeper observations to probe the riddle, seeking mechanisms that could spawn such complexity so early, veiled in plain sight for eons. The most astonishing twist is where it hid, in a sky sector astronomers have scrutinized for decades. Earlier observatories simply lacked the sensitivity and wavelength coverage to perceive it. Hubble imaged this field repeatedly, with countless analyses poring over the frames, yet the crucial details lay just beyond reach. The enigmatic structure may have been shaping its neighborhood for billions of years while remaining invisible to us. It's akin to discovering an entire mountain chain behind your home that somehow went unnoticed. Now, astronomers are racing to revisit well-trodden targets with Webb's infrared acuity, asking what other surprises might lurk unrecognized. Since the first light of galaxies, the universe has cloaked its earliest engines behind dust, gas, and immense distance. Only now has Webb's infrared sight lifted the veil, revealing the long silent scaffolding, filaments of the cosmic web, threading the deep. Under Webb's gaze, once hypothetical filaments now shimmer with faint hydrogen glow, threading together nascent galaxies, while ultra-dim dwarf systems, previously invisible to Hubble, sprinkle the scene like seed bricks of the cosmic skyline. In the Tarantula Nebula, star-forming spires rise like spectral monuments, their dusty shells stripped back to unveil newborn suns. Across stellar cemeteries, the ash of supernovae shines with concealed elements forged in explosive furnaces. Intermediate mass black holes hiding inside dwarf galaxies are reshaping the storyline of galactic growth. Their gravity, subtle but persistent, tugs background light into gentle arcs, and Webb has traced their echoes, hinting at how these middling beasts may have planted the seeds of today's supermassive anchors. Closer to home, familiar worlds gain startling depth. Saturn's rings disclose ghost-like arcs from Enceladus's icy plumes. And Titan's methane weather flickers in shifting patterns, scenes invisible until infrared vision revealed their choreography. Most jaw-dropping of all are primeval galaxies flush with metals and dust. Blazing through star formation mere hundreds of millions of years post-Big Bang. Their spectral fingerprints were hiding in plain sight, stretched into infrared wavelengths that earlier observatories couldn't reach. Each fresh view is a reminder the universe is both our oldest archive and our most confounding riddle. Structures that waited in darkness for eons now step into the light. It's as if the cosmos bided its time until our instruments became worthy of the view. That unveiled tapestry permanently alters our perspective among the stars. The stakes are immense. Our maps may omit key features that could clarify long-standing puzzles. Some scientists speculate these hidden structures might underlie unexplained gravitational oddities we've recorded. The result is a modern-day gold rush, teams worldwide jockeying for precious Webb observing time to comb well-trodden skies for impossibilities that were there all along. Then there's the rule-bending heart of the mystery. This structure seems to toy with fundamentals, interacting with its environment in ways that sidestep our expectations for gravity and energy flow. Observers report energy signatures streaming along paths standard models deem impossible, and lensing-like effects on background galaxies that don't line up with vanilla gravity. A few researchers suggest this could be the first tangible hint of altered gravity frameworks or exotic dark energy behavior never directly seen before. Such moments are the thrill of frontier science, encounters with phenomena that strain the principles we've trusted. In labs, particles sometimes refuse to play by the book. Muons loop with magnetic quirks that strain quantum calculations, and neutrinos ghost through matter, hinting at forces beyond the catalog. On cosmic scales, the Hubble tension pits rival measurements of expansion against each other, nudging us toward new dark energy ideas. Fast radio bursts flash across the sky in milliseconds with stupendous energies, challenging conventional budgets. Gravitational wave detectors have caught mergers among black holes and neutron stars in mass regimes theory didn't anticipate. Even quantum reality needles our intuitions. Entangled systems forge long-distance links that Einstein once dismissed as spooky. Yet they coexist with relativity through still murky mechanisms. These surprises aren't failures, but invitations. They push theory to widen its frame toward unfamiliar particles, veiled dimensions, or recalibrated gravity. Proposals span axion-like candidates, sterile neutrinos, and quantum gravity effects that might stitch experiment to expectation. Every anomaly is a lighthouse marking the edges of our map. Standing here, it feels like the threshold of a new synthesis, one that refreshes our notions of space, time, and matter. By leaning into the oddities, science composes a deeper, more intricate score of reality, a reminder that the universe's next astonishment is likely already waiting, just beyond the current reach of our sight. The coming 10 years are poised to deliver findings that will unsettle even our most basic assumptions about the cosmos. Temperature readings around this object are equally baffling. Sectors that ought to be scorching appear cool, while regions expected to be frigid blaze with intense heat signatures. These inverted thermal patterns don't align with any known astrophysical mechanism. Most startling, the structure's motion seems to contradict standard cosmic expansion. In a distant locale where nearly everything should recede at comparable rates, this object exhibits anomalous velocities, as if resisting the flow of the expanding universe. That has prompted some daring thinkers to float a provocative idea. Perhaps this is the first hint of technologies or megastructures fashioned by advanced intelligences in the universe's youth. Star formation as never recorded. Inside this enigmatic environment, Webb has captured spectacle, stars coalescing through processes unlike anything previously observed. Ordinarily, stellar birth begins when gravity draws gas into a collapsing swirl until fusion ignites. Here, however, the patterns resemble straight, elongated tracks of nascent suns, cosmic production lines more than spirals. These protostars also appear far sooner than models deem feasible, as if star birth were running on fast forward. Stranger still, the nurseries harbor elements that theory says shouldn't exist so early in time. With its infrared acuity, the James Webb Space Telescope is revealing stellar genesis in unprecedented detail. In the Carina Nebula, high-resolution imaging lifts veils of dust to unveil towering columns sculpted by fierce ultraviolet radiation. Each spire, taller than Everest, shelters protostars in dusty wraps. Jets erupt from these embryonic suns, hollowing cavities and driving shocks that ripple across nearby clouds. Along NGC 3324's cosmic cliffs, newborn stars emerge in ruffled halos of copper and sapphire-tinged glow. Fresh outflows pierce dust lanes while shock fronts compress gas into compact knots destined for future stars. This dance of collapse and feedback, frozen in infrared, lays bare the gritty machinery of stellar creation, no longer idealized, but turbulent, with jets and winds that both spark and quench growth. At the Tarantula Nebula's core sits R136, a dense cluster packing hundreds of massive stars within 30 light-years. These blue-white titans shine millions of times brighter than the sun, scouring their cradle with radiation and gale-force winds. Webb's view of R136 clarifies how giant stars remodel their nurseries, triggering fresh waves of star birth even as they disperse raw fuel. Closer in, the protoplanetary disk around HL Tau stands out in striking relief. Concentric rings and gaps betray newborn planets carving lanes through dusty orbits. Spectra reveal water vapor, carbon monoxide, and organics swirling within the rings, the building blocks of rocky worlds. From glowing filaments to colossal clusters and planet-forming systems, Webb is capturing stellar origins in their full complexity. Such insights promise to reshape theories of how stars and planets arise, weaving the earliest strands of cosmic evolution. Typically, the heavy elements essential for Earth-like planets accumulate over multiple stellar generations, yet they seem curiously abundant in this youthful neighborhood. Some researchers speculate we're seeing a previously unknown mode of star formation unique to the early universe. Others cautiously entertain the idea of deliberate stellar engineering, artificial starbirth by an ancient civilization. Whatever the cause, the evidence is forcing a rethink of star formation timelines and the rapidity with which complex elements permeated the young cosmos, an apparent doorway into another era. Perhaps the boldest hypothesis invokes unusual space-time behavior. Several noted physicists point out that the bending and shifting of light around this region resembles a cosmic defect, a crease in space-time itself. A few go further, proposing it could be akin to a wormhole, an Einstein-Rosen bridge, linking far-flung parts of our universe or even connecting to another cosmos. Energy signatures reportedly mirror patterns predicted for traversable wormholes, long thought to be mathematical curiosities rather than tangible structures. If this reading holds, we may be witnessing a natural shortcut through space-time, a phenomenon that rewrites what journeys across the universe could mean. The James Webb Space Telescope, wielding unparalleled infrared sensitivity, truly acts as a time portal, revealing eras long vanished from the current cosmos. Every photon it records began its trek before Earth existed, bearing messages from the universe's earliest childhood. Deep field exposures turn random sky patches into archival panoramas. Ruby red glows betray galaxies that emerged mere hundreds of millions of years after the Big Bang, while nearer systems chart the long arc of star nurseries and black hole growth across billions of years. By decoding delicate shifts in spectral signatures, astronomers rebuild chemical ancestries, witnessing the universe's first heavy elements forged in primordial supernovae. Gravitational lensing supercharges this temporal journey, operating as colossal natural telescopes. Massive clusters like SMACS 0723 bend and magnify ancient light, enabling Webb to probe deeper than ever. In a single astonishing frame, a distant quasar fractures into multiple mirages, each reaching Earth by slightly different routes and slightly different times, offering a layered chorus of the same beacon from stagger moments in cosmic history. These time-staggered echoes sharpen tests of general relativity and calibrate the universe's expansion across eons. Closer in, Webb's infrared portraits of nascent planetary systems capture worlds mid-assembly. Protoplanetary disks glow as newborn planets carve rings and gaps, echoing the early layout of our own solar system. Observations of Titan's methane cycles and Jupiter's high-altitude wave trains reveal weather in motion, hinting at how atmospheres transform over ages. By interlacing sweeping survey mosaics with surgical follow-ups, Webb builds a continuous timeline from a universe's fiery dawn to today's mature stellar cities. Each dataset bridges immense gulfs, inviting humanity to traverse epochs in a single glance. In this sense, the James Webb Space Telescope stands as our finest gateway to another era. Meanwhile, some teams highlight puzzling timing offsets in the light curves, almost as if time's flow itself is distorted near this structure. Background light shows signs of extreme time dilation far beyond what ordinary gravity predicts, though most experts remain cautious about exotic explanations. The anomalies are peculiar enough that even conservative voices concede something highly unusual is unfolding in this patch of sky. Several theory groups are crafting fresh mathematics to explain how such a phenomenon could arise naturally in the early cosmos. What lies within? Webb's instruments have uncovered something even stranger at the core of this formation, an energy source unlike anything in existing catalogs. Is an A, black hole, neutron star, or standard galactic nucleus. Instead, it resembles a compact region generating prodigious power with no visible engine to drive it. The output is staggering, on the order of thousands of supernovae, yet confined to a surprisingly small volume. Most confounding of all is its spectrum. It doesn't match signatures from matter, antimatter annihilation, fusion, or any other recognized astrophysical process. Some researchers have nicknamed a cosmic battery, as it appears to steadily pump out energy without obvious depletion. The central riddle persists: what mechanism could fuel such a source? Shrouded behind cosmic veils, the universe has hidden wonders for billions of years. Infrared observatories strip away dust and gas, exposing star forges buried in the dark recesses of giant nebulae. Within swirling protoplanetary disks, icy grains and organics collide and cohere, sketching the earliest steps toward planets. These disks develop concentric gaps sculpted by newborn worlds clearing lanes in the primordial dust. A number of scientists suggest we might be witnessing previously unseen interactions of dark energy or dark matter. Others argue for a primordial black hole with properties distinct from remnants of collapsed stars. The boldest idea posits signatures of directed energy, perhaps even an artifact from an ancient cosmic civilization far older than expected. Whatever the cause, is forcing a reappraisal of our most basic assumptions about how energy is generated in space. Redrawing the cosmic timeline, this improbable find compels a fundamental rewrite of our chronology of the universe. For decades, the narrative seemed clear. Light elements formed first, then simple stars, then heavier elements through successive stellar generations, culminating in complex galaxies and diverse planetary systems. Yet this object displays levels of complexity that, by standard timelines, shouldn't appear for billions of years. It's akin to discovering modern skyscrapers in ancient Mesopotamia. The know-how to build them simply shouldn't exist yet. Astronomers now confront a stark dilemma. Is our entire chronology of the universe flawed? Or is this object an extreme outlier? If the former, curricula demand wholesale revision. If the latter, what peculiar conditions could have turbocharged evolution only in this locale? Some teams argue that special seed zones may have matured far faster than their surroundings, creating islands of advanced structure amid a largely simple early cosmos. Others entertain bolder ideas, such as relic material persisting from pre-Big Bang conditions. Either way, the tidy, linear story of cosmic development is under serious strain, and researchers are racing to fold this paradox into a revised picture of how the universe assembled itself. Implications for our future. This landmark Webb result doesn't just recast the past, it expands the horizon for what lies ahead. First, it demonstrates that our cosmic charts and models omitted major features, implying vast, foundational discoveries still await. If something so consequential could sit unseen until now, what else might emerge with next-generation observatories? The strange physics near this object has already catalyzed fresh theories for propulsion and power systems. If we can decipher how it appears to steer gravity and energy beyond present frameworks, the payoff could be transformative technologies. Some optimists even speculate that probing this phenomenon might one day inform concepts for superluminal travel or practical gravity control. The finding has also revived discussion about ancient technological societies. While mainstream opinion leans toward natural explanations, the object's intricacy and odd behavior lead a few to wonder whether we're witnessing remnants of cosmic-scale engineering from eons past. Whatever it proves to be, the structure is a bracing reminder of how much remains unknown. Just when it seemed the grand narrative of cosmic evolution had settled, Webb unveiled a rule breaker, underscoring again that the universe is stranger, richer, and more astonishing than expected. Thanks for tuning in to another episode. Before heading out, check the video on your screen for more in-depth explorations.